I'll kick off then and just say a few words to open and give an idea of what it's all about. So for those of you that don't know me, my name is Barry Cranford. I'm the founder of the LJC, and I'm not a developer myself, but I'm in fact a recruiter. I run a recruitment company called RecWorks. So as for what I'm doing here and what today's about, well, firstly, I'm a huge fan of careers in general, and the various different things that people can do to get ahead. But working in recruitment's been pretty cool for me, because you get to study people's careers. You get to watch the little things that people do differently to get ahead. So in truth, when I set the LJC up 13 years ago, I don't think I really knew exactly what I was getting into. I think I had the image of a smaller group, 200 or 300 people maybe, but it's become this enormous community. So it's about 7,500 people now. It's getting cool. So for like a career geek like me, seeing all these different people, all these different careers, and who's out there and loving what they do, and who's sticking in the same things is interesting. So when we've built RecWorks, we've built it around this concept of trying to make recruitment a force of good in the industry. So trying to find ways that we can take our network and put people together and for the benefit of the whole industry. So a lot of the work that we do sits somewhere between giving back to people we've worked with and paying forward to people that we will hopefully meet at one day. So it's all powered by revenue from recruitment. So if anyone's thinking of hiring, or anyone is hiring, please bear us in mind. Anyone's looking for a role, or again is thinking about it, then please give us a shout in the future. A few examples of what we do. We've run now 600 events, LJC events. We've made over 2,000 personal introductions through our mentor community, and we've helped provide platforms for loads of people that have gone on to become conference speakers and really get ahead that way. And that is exactly what today is all about. And we ran our first one 2 weeks ago. So we've got Zam and Rafał who spoke at that one. And this is something I'm hoping will be a consistent thing, where we can run this every couple of weeks and provide new speakers or developing speakers a chance, a platform to speak and to get better. For me, in terms of watching people's careers, it's pretty much the best thing that you can do to get ahead. So benefits you might not know about. Firstly, it raises your profile, which is obvious. People start to know you that didn't know you. That naturally leads to internal promotions when people hear what you're doing, to new job offers and that kind of thing. But one of the coolest parts of it, and I only found this out at the last LJC conference, and it was Abe and Daniel Bryan that were saying it helps you connect with people that are doing the same thing that you do. It helps you to connect with these incredible people that truly will make your life better, your career better. And yeah, just like try it and tell me I'm wrong, but obviously communication skills and all that kind of stuff as well. So yeah, and they're fun. So it seems like the perfect thing to have over a lunchtime, not too serious, nothing too heavy. So feel free to eat, get coffees, have kids, partners walking past is all okay. Anyway, I hope you all enjoy it. So yeah, I hope everyone has a good time. And with that, I will get out of the way for Stathis, who's going to give a talk on instant tests for the endpoint agent, I believe.
Right. Let me share my screen. Okay, suppose anyone can see my presentation now. So, hi everyone. I hope basically that everyone is safe and well. Thanks for joining me today on this lightning talk. My name is Stathis Souris. I'm a senior software engineer for ThousandEyes. And today I'm going to be talking about instances for the endpoint agent, or basically how we build a system to collect and visualize metrics from end user machines near real time. So a few things about ThousandEyes. So ThousandEyes offers a network intelligence platform where you can proactively monitor the performance of your critical business applications, and you can correlate all that with the global internet health and also ISP outages that are ongoing. Or if you are a person of few words, we're basically the Google Maps of the internet. Regarding the product I'm working on, the endpoint agents, basically they are applications that run on the end user machine, laptops or desktops, and they collect various interesting metrics, application level metrics, network level metrics, and path traces, and many more things. So these agents, they regularly check in with our backend, and we put that event into Kafka and hold that thought for later, because I'm gonna be talking about this in a bit. And we use something that we call the agent label we use that to group agents in, for example, by location or by their access point, or a combination of many more filters. So how did we get to instant tests, right? And what is instant tests in general? So as I said earlier, we have the agent label that we use to group agents. And then after we build that, we basically started building something that we call the schedule tests. And schedule tests are just synthetic tests that run on the endpoint agent. And they collect, again, application metrics, application level metrics, and network level metrics, and path traces, and they send it to the backend. And we build a Kafka Streams application that I show on the right, like a diagram, where we consume from the Checkin stream I talked about earlier. We combine with all those tests that the user has configured and the labels, and we kind of emit a list of assignments. And this happens from this event stream. But we got feedback from our customers that they wanted to see changes of their tests near real time, because now the agent would go to our backend every 10 minutes, would poll our backend and get those test configurations. But the customers didn't like this. So we built a Websocket layer on top of the scheduler, basically, that keeps an always-on connection between the agent and the backend. And now when there is this change from the scheduler, they will immediately be notified of that change. So we fixed that in a sense. So the next natural step was instant tests. And instant tests, they're very similar to schedule tests. They're basically the same thing, but the difference is that they only run once, and they serve a different use case, right? You can just run them whenever you like. You don't have to schedule something that runs on a specific interval and have, for example, restrictions on how many tests you can run. You can run it on any agent regardless of how many scheduled tests it's already running. And you can use it for troubleshooting your network of one of your employees, for example. And now, very fast, a little bit of the functionality that we offer. We have the run once functionality. It's a similar thing as a schedule test. You could just configure, you select the label and you press the run once button. And then you get redirected to the instant test view, where we saw all those metrics I discussed about earlier, all those application level metrics and network level metrics and the path traces in one round. And you can, if you want, rerun this again, you can create a separate round with new test results. Now, regarding the backend, so of course, it relies heavily on the WebSockets. We build this Kafka Streams application where we store. It consumes from the Checkin stream, and it stores into Redis the active check-ins in the system. And we basically query that, and we get very fast back a list of agent IDs that they match a specific label. And then we correlate those list of agent IDs with the agents that actually have a WebSocket connection, because sometimes, because you don't control the network that the endpoint agent is deployed in, we have to know which agents have a WebSocket connection. So we combine these two lists and we create this instant test configuration. We save it into MySQL, and then we publish it into Redis, from where the WebSocket servers will already be listening on and will immediately notify the agents that they need to run this test. Regarding the Checkin Reconciler, it's a Kafka Streams application. It used to be a vanilla Kafka Streams application with state stores and interactive queries, and we used to repartition the Checkin stream with a different key, but it didn't scale very well after a few thousands of agents. So we had to instead replace the state store with storing everything into Redis, and this works really well right now. And it's a really fast service to answer these kinds of questions, which agents actively right now match a specific label. Regarding the WebSocket layer, it's based on Spring Boot. It's just a vanilla Spring Boot app with a WebSocket server. It uses a Stomp protocol. Agents subscribe to a Stomp topic when they're connected for the first time. And we keep the state of the connected agents in Redis. And we do that because there was no way from the Spring Boot WebSocket server to get that state in a distributed manner. You could get that state inside an instance, but you couldn't get it when you were scaling these WebSocket servers. And of course, we offer this functionality from the developer API. You can create agent labels, you can create an instant test, you run an instant test, get those results. And we actually used it a couple of weeks back, and we built the Slack bot ourselves, and we won the hack day. And with that, and I leave you with that. I have some links here. If someone is interested, you can take a photo. I have my Twitter handle. And yeah, that's it.
Great, thank you very much, Stathis. Does anyone have any questions then for Stathis at this point? No, all good. Okay. Well, thank you very much for that. Please, everyone, show your appreciation in the chat. We'll give a little clap, and yeah, we go. Got some rounds of applause going around there. I did say we needed to get some sound effects for this one, so that's something we need to look into in the for the next one. Next we have Ilan with a talk, possibly my favorite name for a talk that we've ever had. Cowabunga, a quick walkthrough of end-to-end CI/CD using DigitalOcean, Kubernetes, Dockerhub, Travis, Gitops, and magic pixie dust. So Ilan, take it away.
Let me share my screen. Check I'm sharing the right one. And share. So I assume you can see my screen. Okay, great. So I'm going to click start there so I can see how much time I've used. So what I'm going to really show you is how I'm doing the DevOps, GitOps, CI, magic, everything with a website that I'm working on in the evenings that does visualizations of what's happening in the world right now with this crazy epidemic. It's a way I entertain myself, and it's also letting me understand what's going on. It does various things, it normalizes, and it various ways, and you can explore for hours. I quite enjoy myself with this. Now, I'm going to show you how this is deployed when I make a change from commit all the way through to the productive app. It's running on Kubernetes in DigitalOcean. So I'm running a DigitalOcean cluster, and kudos to DigitalOcean. They've agreed to sponsor me, so I'm not paying the costs, but if I go look at the billing, you can see it's only $20 a month anyway, because DigitalOcean is cheaper than anything else. So that's running there. The code is all open. It's in GitHub, so you can see it on the right here, and it's running a server that's written in Go. Now that's the entire web server, small. You can find all the code. So take screenshots as I talk, because you can see where everything is if you want to remember where anything is. So this is just running in GitHub. The source is all open. And the Kubernetes side is all being done through something called Gitops. So that's also a wrong click there. Now I can't see the front. Okay, so that's all running in another repository that's got the Gitops repository in it, which you can find here. And as I said, that this is running in Kubernetes. So I'll open up the Kubernetes dashboard so you can see the website. That's these two at the top here, the Corona app. And here on the right is the Gitops repository. So I'm just going to make a quick change now so we can see it all happening. This is my editor. I work always online in GitHub, because who needs an IDE? So I'll go in here and I'll edit it just to show you. So this will happen live, and I'll change that to 3 replicas. I'll commit that change. And we'll just let that run while that's going on. Now I'll go back to my repository here. Oh, I can't get to the top of these things. It's a bit annoying. If I click minus. There we go. Yes, this repository. So I'll also go into the code. So here is the server. Come on, GitHub. And here's the index.html. Okay, so we'll have that open here. And if I go to the right here, here's the app, and you can see I've got a little button. So I'll make a quick change here. I'm going to edit it. And I'm going to look for the is the search working? Yep. So I'm going to look for the name of the icon. You can see on the top there, that little heart. And I'm going to change that to a cake. I'm going to commit that change. Okay, so that's all going to start running. Now, in the repository itself, you can see I'm running Travis and Docker. The Docker file itself is quite small. That's the entire Docker file. And then if you go back to Travis, you can see the Travis YAML here. You click that. That's, again, it's a very simple Travis YAML. I'm not going to dig too deep into that right now because I don't have the time. So this is the Travis running. So you can see Travis is running and about to start building. I believe, yeah, it's running for 20 seconds. Now, if we go back to the Kubernetes dashboard, we should start you'll see as this pulls through, I've also got a Flux running. That's part of Gitops. So the way Flux works is it runs within your Kubernetes cluster and it monitors your GitHub repository, and it also monitors Dockerhub, which if you look over here, the last release was 2 hours ago, so that should change to a few minutes ago, because if you look on the right-hand side, this is now busy deploying to Dockerhub. So you can see the Travis has now pushed it to Docker. It says pushed, I assume. If we refresh on the left-hand side here, you'll see that now I've updated the Dockerhub from that one change a few seconds ago. Flux will now be monitoring that, and we'll see any second now, we'll start seeing these two changing as Flux picks it up and then notes that there's a new version of the container running within Docker. And you'll also notice that, remember, I changed the number of replicas from 2 to 3. So you can now see I've got 3 and one's been running for 12 seconds. As the other change picks up and goes through, you'll start seeing that the actual different, the different apps will start redeploying. And then we will see on the left-hand side here that this will change to a picture of a cake. See, it's still a heart. And I've got a few seconds left, so let's hope that Flux picks it up fast enough. Otherwise, I'm going to run out of time and the world's going to end. While we're waiting for that, let me show you some of the other parts of the repository. I think I'll click here. So the repository is running using, it's live because it's connecting directly to the Johns Hopkins source over here. Let's see, does that come through? Come on, come on. And there we go. So now you can see at the top here, the first app is redeploying. The second one here is redeploying. Because it's Kubernetes, it keeps one up the whole time, so there'll be 0 downtime. This is a 0 downtime deployment of my changes. And if you go back here and we hit refresh, there's now a cake. So that was complete end-to-end deployment from commit to production using GitHub as the IDE. My name is Ilan Pillemer. I'm the only Ilan Pillemer in the world. So if you Google me, you will find me. I'm in LinkedIn, I'm on Twitter, and I have websites. Thank you.
Brilliant. Thanks, Ilan. Appreciate that. Again, everyone, please say thank you to Ilan. Use the chat, use the icons, anything that you can to heap your praise. Yeah, got there just about in time. I like that.
Almost. I think I went over a minute.
Okay, I should say as well, we're going to finish this session with some breakout rooms after all the lightning talks are done. So if there's anyone in particular you want to be in a breakout room with, then let me know. But we'll come on to that. We've got 4 more talks before we get to that. So next up, Alex O'Neill, are you out there? Are you ready?
Yes, I am.
Yes. Perfect.
All
okay.
right.
So Alex is going to be speaking about ring buffers in Java, demystifying the much beloved ring buffer data structure.
Great, thank you very much. Okay, can anyone see my screen okay? All right, I can't see anyone, so I'm going to assume that's yes.
I can't actually
at the moment.
No? Ah, okay, 1 second. I'm just going to give this another try. Damn it. What is going on?
Alex, do you want me to move on to the next one and come back, or are you good?
Yeah, 1 second. I don't know what's going on with Zoom. My apologies. I'm just going to try this again. I'm just going to try this once more time.
That's good.
Okay.
Yeah, we got you.
Is that good?
Yeah.
All right, great. Thank you. I just wanted to go over ring buffers in Java. Why did I want to go over ring buffers in Java? Because I think they're just a very cool data structure. The implementation of them is pretty succinct and elegant. I think we'll go over that. And in Java itself, there's actually a ring buffer implementation in the standard library. And I suppose you don't really see it used that often, but if you do, great. And I will just quickly go over that as well. So I just really wanted to go over what they are, the standard Java implementation, and maybe some use cases you wanted to have in your own projects as well. Now, what is a ring buffer? A ring buffer is a fixed size buffer, like so. It acts if it's connected end to end. You can use it as a first in, first out queue, last in, first out queue. I suppose some implementations like linked list and stack you can maybe compare it to. But I think what makes the ring buffer extremely interesting is that all the queue operations are constant time. And if you wanted to check whether there's actually items in the queue, that's also constant time as well. How does it do this? It does this by having pointers. So you have a head and you have a tail. And wanting to check whether the queue is empty, you just see if the head is equal to the tail. As we can see here in our example, the head is equal to the tail. So that is how we know it is empty. If we wanted to add a value to our ring buffer, we just look at where the tail is pointing to. We add our value and we bump the pointer. We wanted to add another value. We do so again. We add our value and we bump the pointer, like so on and so forth, until you run out of time making slides, which I did. So that's how you sort of add values, and they will keep on going around unless it meets the head. Now, if we were to pull values out from the ring buffer, how would we do that? We'd look at where the head is pointing to in our backing array, and we can see that it's pointing to 2. We'd pull it off, and we'll bump the pointer. Now, depending on your implementation, what you could do is that you could null out the entry for 2, or I suppose some implementations, what they like to do is that they actually like to just leave the object there, and then when the tail reaches back around, they can actually reuse the object as a sort of optimization as well. It really sort of depends on what type of implementation you want to do. The one in the Java standard library actually just nulls it out for garbage collection, so there's no references to it anymore. Now, I'm talking a lot about the sort of the standard library implementation. It's not called ring buffer, it's actually called the array deck. It's in the standard library. It implements the collections interface. It also implements the deck interface and the queue interface. So if you wanted to replace anything out, you could just do it like that. It doesn't allocate or copy anything. It's highly space efficient, and it's resizable. How does it do it? It has a head, it has a tail, and like we said, it has an underlying object array as well. Object array because of Java's type erasure. And it pretty much works exactly how we were describing earlier. And in terms of the resizable element of it, the way that the implementation is done in the standard library is that it's actually a power of 2. And if the tail reaches the head, it will actually dynamically resize to twice the size. Why does it use a power of 2? It's a pretty neat implementation. If we go back to our underlying array buffer, we might have, in our case here, 8 elements in our array, and we have the tail pointer pointing at, let's say, the position 7. Instead of having to do modulo operations what the implementation does in the standard library is that it actually does a bitwise and that will make things a lot quicker for the calculations. You can see it done pretty much all over in the ArrayDeck implementation. If we take our example, we can see we're at total 7. If we wanted to add another element, that would give us 8. And we would AND it with the elements.length -1, and that would wrap us back around to 0 again. Now, for maybe your use cases you would use this for, you might want to create a buffer where you were reading and writing at different speeds. You had a producer-consumer type problem. Or you maybe wanted to just replace your queues. If you anywhere you have your queues, you can really just pretty much just place this in and see if you get any sort of speed improvements. Maybe you want to create a real-time processing application where your old entries are discarded, or you wanted to have like a rolling window. You could just delegate to the ArrayDeck. It's really nice. I'd highly recommend using it in some of your projects. I suppose a real-world use case would be network cards. You see a lot of network cards, what they'll actually have implemented underneath is actually a ring buffer, which would be fixed size, and they would add elements underneath until it's full. It doesn't resize, and in that case, it would probably drop messages usually as that occurs on the network cards itself. But yeah, maybe if you're having your next project and you maybe see a good use case for it, it's worth giving the ArrayDeck a try. Thanks for that. If anyone wants to get in contact, you can just contact me on my LinkedIn. Cheers.
Great, thank you very much, Alex. Does anyone have any questions for Alex on that one? Feel free to raise your digital hands or just shout out. No, nothing there. Okay, cool. Well, yeah, thank you very much. Appreciate that then, Alex. Right, we're going to move over then to Bruno Schroeder. The topic of Gen 2 Linux, a very technical introduction to, is it Gen 2 Linux distro? Bruno, are you there? I hope.
Unmute. Yeah, I'm not ready. Can I?
Of course, no worries. We'll sub you in with Karsten then. Karsten, are you ready?
Yes, I am.
Yeah, not amongst the stars anymore. No worries. So Karsten Silz is going to be speaking about Eclipse OpenJ9, a memory diet for your JVM applications. Yeah, Karsten, take it away.
Okay, thank you. Can you see my screens? My screen? Okay, great. Yep. So thank you. I'd like to talk today about how Eclipse OpenJ9 can put your JVM applications on a memory diet. I've got the slides and the source code in a GitHub repository, and I'll share the link at the end of my presentation. So do you care about how much memory your JVM applications use? And can you actually pick your JVM? If you do, then you should take a look at Eclipse OpenJ9, because with Eclipse OpenJ9, you use less container memory, and that achieves lower cost. So what exactly is Eclipse OpenJ9? Well, IBM had an in-house JVM called J9. It powered all of their Java products like WebSpheres for many years, but in 2017, they donated it to Eclipse and called it OpenJ9. So generally, it's a plug-in, a drop-in replacement for Oracle Hotspot JVM, but not all the Hotspot JVM options and tool work. You can actually get it at Adopt Open JDK. So if you go there, you see this little radio button on the right, OpenJ9. You can download it for Mac, Windows, and Linux. And of course, you can also get Docker images. Now let's look at some benchmark to see what really OpenJ9 does. So I ran these benchmarks on my MacBook Pro, used Docker Compose. The Java containers were limited to 2 CPU cores and 2 GB of RAM. Just some plain Java options. I gave 1 gig of heap memory. And for OpenJ9, I also used an option to lower CPU and memory usage at the cost of some slightly reduced throughput. I measured CPU and memory with Docker stats. So these are not scientific benchmarks. That's why you can actually run them and tweak them yourselves with the files that you find in my GitHub repository. So onto the benchmark. The first application was a web application. I generated it with JHipster, standard, Spring Boot, Spring Data with a Postgres backend, Angular 9 for the front end, 11 screens all in total. I started the application, took measurements, then used the application, all screens, uploaded some data, measured again, and I did that 3 times for all of the JVMs. So on to the results. So what did I see? If I looked at Hotspot, Hotspot used about 600 or 400 memory right after a startup. OpenG9 runs circle around that, just 200 max after startup of the entire application. So for Java 8, it uses a third of the memory, and for Java 11, it just uses half of the memory. Then I used the application a bit. How did that change things? Well, Hotspot used some more memory and actually got better in Java 11 again, used a little less memory. OpenG9 still beat it. So if we're looking at the numbers, it uses about 2/3 of the Hotspot memory in Java 8 and about 4/5 in Java 11. Now, maybe the startup time as reported by the Spring Boot application is actually faster with Hotspot. You know, after all, it uses more memory, but we're actually wrong. It isn't faster. Let's spoil it. So Hotspot did get faster with Java 11. It wasn't enough to beat OpenG9. So OpenG9 did get a little slower, but still beat Hotspot in both cases. So it needs just 70% of the startup time in Java 8 and 90% in Java 11. So on to the second benchmark, that is just pure number crunching. I use the open source benchmark Renaissance suite. This is just pure Java Scala code. There's no external database, no web request. I picked 7 of the about 30 or 40 benchmarks and I ran them 5 times each. So the average memory usage over these benchmark runs in Hotspot got a little worse with Java 11, hovering around 1100 megabytes. OpenG9 really just a little more than half of that memory. So in both Java 8, Java 11, it uses just half of the memory that Hotspot does. Now, I actually did stop the time that the benchmark took to finish with the time command. And if it, lower numbers are better here. So Hotspot did actually get worse. It took longer in Java 11 than it did in Java 8. OpenG9 here was beaten for the first time. So if we're looking at it, it takes about a quarter longer than Java 8 Hotspot and just a little bit longer than Java 11. And I think that is a result of that tuning parameter that I set, where I said less memory, less CPU usage, but at the cost of a slight reduction in throughput. And that slight reduction in throughput is what we're looking at here right now. So to sum it up, OpenG9 uses about 40 to 80% of Hotspot's memory. It starts faster, but for pure number crunching task, it's probably slower. So are there some cases where you cannot use OpenG9? I mean, it sounds pretty enticing, it uses a lot less memory. And yes, there are some cases. So I could just imagine 3, your tool chain requires another JVM, maybe use the flight recorder from the Hotspot JVM. Maybe your licensing model doesn't allow for OpenG9. You've got a support contract with Oracle, or maybe OpenG9 is too slow for you. So to sum up, Eclipse OpenG9, it uses less container memory and it achieves lower cost. So if you want to find the Docker files and instructions on how to use it, here is the QR code and here's the link. And that is the link to my GitHub repository where you also find the slides and everything else. Thank you.
Brilliant. Thank you very much, Karsten. Appreciate that. Does anyone have any questions at all for Karsten on that presentation at all? No problem at all. All right, well then heap your praise in the chat. Feel free to talk to him afterwards in the breakout rooms. Bruno, you're ready. Cool. Okay, I'll hand over to you then for the presentation on Gentoo Linux, a very technical intro to Gentoo Linux distro.
Yeah.
Take it away.
Sharing. Whoop. No. Mac. Oh my God. Mac's asking for permissions, of course. and I will have to, should I quit? Can you see my screen?
I can just see your name at the moment.
Yeah, I'll have to restart so that I can, sorry, it's
That's
permission.
fine. That's
Okay.
fine. Should we go on to Rafał and put you to after Rafał?
Yeah, of course. Thank you.
Perfect. Rafał, are you ready then? Are you out there somewhere? Can you hear me?
Yeah, I'm ready.
Good. Okay.
Can you hear me okay?
Yeah, absolutely, absolutely. So Rafał, your talk is send it to Elasticsearch again.
Again.
Nice. Okay,
Exactly.
Cool. Enjoy.
All right, let me just share my screen. All right, can you all see my screen?
Yes.
All right, let's kick it off. Hi guys, hello everyone. Great to have you here. Today I'm going to present a talk called Send It to Elasticsearch Again. My name is Rafał Foltyński, and there's my Twitter handle below. I'm a senior Java developer in LMAX and also an open source contributor. And today I'm going to talk about one of the features that was on a very high demand in my open source project called Log4j to Elasticsearch. So Log4j to Elasticsearch is a Log4j2 appender that is capable of pushing logs in batches to Elasticsearch clusters. And if you're familiar with Elk, the applications are usually writing these logs to disk, which are picked up by Logstash and delivered to ES. This plugin allows you to push your logs from the application to Elasticsearch directly. So the architecture can be broken down to a very simplified view of the appender, batch delivery, and HTTP client. The appender serializes the Log4j events, puts them in the batch delivery. Batch delivery creates a batch of a request containing all of the collected logs, ships them to HTTP client and delivers to ES. This architecture can be extended with a failover policy, which can store all of your failed logs in a ChronicleMap, and then the retry processor can pick them up and deliver to batch delivery again. So what is the ChronicleMap retry failover policy? It's a component that writes failed logs to ChronicleMap, which is a file backed in-memory store with a map interface. Check out their GitHub repo. The Open HFT repo has a lot of awesome components. It also uses the retry processor to schedule the retries, and a class called key sequences, which I've created to manage all the IDs of failed logs that can appear in the system. Have a look at also have a look at the full documentation on my repository. So a ChronicleMap can be very easily used as a regular map. One new thing that I've created is a key sequence which can serve a next writer key and next reader key. Next writer key is obtained once the failed log arrives, and we would like to use this key to put the failed log inside a map, and then the retry processor can take the next reader key to get it out of the map. But the actual issue that I had was that ChronicleMap needed a char sequence keys, and since it's a map and we are operating with failed logs, we would really like these IDs to be unique so that we don't overwrite any of the previous logs. But what I also wanted to have is a full control over this char sequence. So the first thought was to use UUIDs, but UUIDs are random unless we create a special data structure to actually tackle the predictability of the IDs. So I've created a class called key sequence, which can which can serve any of the IDs that can pop up in the system. The key, every ID is created, contains two numbers. The first number is the identifier of the key sequence. The second number is the identifier of the object within a key sequence. Now you can have multiple different key sequences within the same ChronicleMap, and this way, since ChronicleMap can be shared between Java processes, multiple applications can write into the same ChronicleMap and have their own isolated space for their failed logs, represented by a set of IDs. And in this case, UUID can be very nicely used to format my two numbers and represent a very large number of IDs within a key sequence. Also, there are two additional elements called writer index and reader index. Once the failed log arrives, the writer index will point to the next available ID and just get incremented. And then retry processor will increment the reader index. Reader index will chase the writer index, and once they are equal, there are no more items to retry. Also, this design also allowed me to. Can you all see this? Oh, hold on. I don't want that. I don't want that. So this ID design also allowed me to designate some of the IDs for some special data structures, like a pair of two zeros will point to a list of all available key sequences. Then the IDs of the key sequence, ID of the key sequence listed in this list will point to key sequence states, where I will just store the reader index and writer index, and these reader index and these reader and writer indices will be then used to resolve any of the IDs of the messages that need to be retried. Let's have a look at the example failure scenario. Notice the three logs, three hello world logs trying to be sent to ES. Once any communication error, connectivity error arises, the logs are redirected to the failover policy. Failover policy picks up next writer keys. Then the retry processor, since writer key is ahead of the reader key, will just chase them up. Will just chase the writer key until they are equal. Try to deliver them again. Physically remove them from ChronicleMap. If the connectivity problem persists, failover policy will just store them again using a set of new writer keys. Retry processor will again pick them up, and if the connectivity is restored, the logs will eventually get delivered. Let's have a look at the live demo, shall we? So what I'm going to do now is I'm going to send 100,000 logs at the rate of 1,000 logs per second to a running Elasticsearch node, and I'm gonna kill Elasticsearch in the middle. So you can see the current rate, and also you can see the number of enqueued logs to retry. At the moment, it stays at 0, which is great, healthy system. But let's kill ES and see what happens. So suddenly, well, we are bombarded with tons of connect exceptions. Let's bring ES back to life. These logs are getting redirected to the ChronicleMap failover policy, and numbers of enqueued logs and total keys are starting to increase. At the moment, we have something like 22,000, 23,000 failed logs to retry. So we have the current delivery of logs that is running at the rate of 1,000, which are stored in the ChronicleMap, and also once in a while we should have a retry processor trying to retry 5,000 of these items and deliver them again. All right, looks like ES is healthy now. Logs are being delivered to ES again, and number of enqueued logs slowly drops. I've configured this retry processor to send 5,000 elements every 4 or 5 seconds. Let's have a look at Kibana. And we got a full success, 100,000 logs. 100,000 logs delivered to Elasticsearch after the connectivity issue. So there are still a few issues with this approach. This policy does not like the kill minus 9 log delivery can fail in some scenarios. So I highly encourage you to test test various different configurations before you go live. But the bottom line is that your log delivery is finally safer than it used to be. Check out the projects. If you would like to improve it or work on some more features, feel free to join me. I'm looking for contributors. Check out the documentation of the failover policy and also ChronicleMap. My Twitter handle is included. I will post the slides to this presentation later today. And that's all I have today. Do you have any questions?
No, great. Thank you very much, Rafał. Appreciate that as a follow-up. Are we going to get you back again, do you think, for the hat trick?
I will have to think about another topic.
About the content.
But yeah, sure, why not?
Brilliant. All right. Well, thank you very much.
I didn't have too much time to prepare this one, so hopefully next time I'll be prepared a bit better.
Brilliant. All right. Well, thank you very much. Appreciate that. And yeah, everyone, please keep the comments coming. Seeing a few coming through thick and fast at the moment, so that's great. And for the final talk before we go to the breakout rooms, Bruno, do you think your Mac's gonna cope?
Let me try to skip. I think I already gave all permissions. I think you have the person who is screen sharing should close before I can.
Yeah, let me. Rafał, can you do that? Can you drop the?
Yeah, sure. Hold on.
Thank you.
Nice. Here we go.
So, sure. Can you see my screen, guys?
Yeah, absolutely.
Brilliant, brilliant. So this is Gentoo Linux. I changed the subtitle. It's very technical and very passionate. So I'm Bruno Schroeder. I'm Latin American, so I'm passionate. If you don't want to hear something passionate on a Friday, you just turn off the audio, please. So I worked many years as an enterprise architect. And I think this presentation about Gentoo is something that I met during my life more than once. And I hope you say, wow, this is awesome, this is great, this is delightful, this is cool. So I think Gentoo is very cool, very, very interesting piece of software. So the audience for this talk is, sorry, yeah, so not the best title for this. So I'm not the specialist in Gentoo, still in the introduction. But what is Gentoo? They define Gentoo as an operational system that can be automatically optimized and customized for about any application, any need. So it's all about configurability. And I met Gentoo through the performance through the performance guys, the performance engineers, but also a lot of people in security uses. So the audience, this is the slide on audience. These are my personal prejudices. Who do you think should go for Gentoo? People who love software, people who likes computer science per se, people who like to read documentations and learn from reading documentations, people who loves control, flexibility, customization, who is attracted to very high-tech, cutting-edge technology and robust solutions. And then also philosophical people, poetic people, rebel people, idealist people. And this comes from the Gentoo philosophy. So Gentoo is an operational system that has a philosophy page. And when you read some of the philosophical statements there, you see poetry, you see rebel. So you see, for instance, this one here, it's pleasantly and efficiently as possible, as they see fit. So Gentoo should be a pleasant experience. So our tools should be a joy to use and should help the user to appreciate the richness of the Linux and free software community. So it should be a joy to use Gentoo. And the flexibility of free software. It's only possible when the tool is designed to reflect and transmit the will of the user. And then it goes on. If the tool forces the user to do things in a particular way, then the tool is working against rather than for the user. When I read this second statement here in the philosophy, I think that they are rebels completely, but there is a lot of truth in it. The goal of Gentoo is to strive to create near ideal tools. This is brilliant. So I think from my experience that Gentoo is not good for people who don't have time, okay? Or if you don't have time to read documentation, maybe you shouldn't even look into Gentoo. But it's interesting because Gentoo is used by the tuning community. So if you really tune something up, you can save time. Some processes that are running and take weeks to run or many nights could be run in minutes. And this is done if you know very well how to use Gentoo. So free software, I think you guys don't need it. Bootstrapping. So just for you to now understand Gentoo. Well, I think most of you here know what's bootstrapping is when you build the tool from itself. But Gentoo takes the concept of bootstrapping from computing to the furthest level possible. So you always have to compile the kernel, the whole kernel. So it can be slow. You have to compile the whole kernel for the hardware you are using. So Gentoo can be running a wide range of hardwares. But one thing that is awesome is you can compile Gentoo in a distributed cluster. So at home, you can have several old machines and new machines. And when you compile the kernel, all of those machines in the cluster are going to compile for you. This is really unique in Gentoo. Of course, you can use a USB pre-built image. I don't know my timekeeping. Sorry, I don't have it here on my screen. If someone could just shout.
You've got about 4 minutes, 4.5 minutes, I think you're at the moment.
I used 4?
You've used 4.5, yeah.
Okay, well, there's not a lot left. So just to say, configurability, we have in Gentoo what's called use flags. And use flags is where you turn on and off packages. And with that, portage, which is the package, the package distribution system, is going to compile anything you want to install using your use flags. So you can really customize your Linux operational system to the level of substituting one to the other package in a very low level. And that's why this is so interesting. And portage is so fun, it's so great that they handle conflicts and they handle circular dependencies. So it's the only package management in Linux world that handles circular dependencies. There are some brilliant tools already available. And one interesting thing about Gentoo is Larry DeCal. So Larry DeCal was a bit frustrated at the Linux distros until he tried Gentoo. So if you love Linux and you're a little bit frustrated with what you have, you should maybe try Linux. You should maybe try Gentoo. So I'm open to questions.
Thanks, Bruno. Any questions for Bruno? Then anyone can raise a digital hand on Zoom, or just shout out if you've got something on Gentoo. Then no, nothing direct. Okay, brilliant.
Or maybe someone also loves Gentoo. I think it's a time to express this love. And
Bro, okay.
People try Gentoo then.
Yeah, this is it. I think you've inspired a few people there. So, well, thank you very much. Then, really appreciate that, Bruno. Again, please keep your praise in the chat. Add the reactions. Yeah, really appreciate that. So, we're just on the hour now. So, feel free if people have got to go. How many have we got still hanging on? 42 people still there. What we're going to do, we're going to open the breakout rooms now. So, last time we tried this. So we've done, I don't know if you guys have used, some of you probably have, some probably haven't, but the breakout rooms feature in Zoom, it's one of my favorite features. It's pretty cool. You all just get put into these different rooms, groups of 4 or 5 people. Zoom does it all automatically. It's worked in some rooms, it didn't work in others. So what we're gonna do is, this time we've got different subjects. So in room 1, we're gonna have JVM performance. Room 2, Kafka. Room 3, Kubernetes, room 4, architecture, room 5, machine learning and AI, and room 6, open discussion. So I'm just going to put that in the group down at the bottom. So like I say, you can feel free to head off now to sign off, but if you're interested in joining in one of those rooms, I'm going to press the button now. So everyone will just, I think you'll see something and it will say join. If you want to go into specifically one of those rooms and you don't want to be in the room you're in, just chat to me directly on here, send me a message and I can move you into that room. I don't think there's a way that you can do it voluntarily, but send me a message and I'll do what I can to put everyone in the room they want to be in. But no, thank you very much for coming on, for signing on. Thanks especially for all the speakers. Really appreciate that. And for, yeah, hope everyone enjoyed it. So I'm going to hit this button now and I'll see you all next time.